Welcome to Lawrence High School.
Miss Ortiz, 9th grade geometry class. You see, was it that hard?
Yeah.
Paper. All right, so let's all take out our paper from Friday. If you lost it, I have extras. Okay, if you never got it in the first place, I have extras. That's okay. I will be watching to make sure you're not on your cell phones. Remember what I told you, term 3, video games, cell phones, put them away. You can close your Chromebook. You don't need your Chromebook right now. All I want to see is your papers from Friday out on your desk, please. It's okay. If you lost your paper, that's okay. Tell me. I'll give you another one. All right, so first off, this is Dave. Everyone say hi to Dave. Okay? Dave is recording me, and you guys are all doing me a favor by being here today, okay? So let's have fun. Don't worry, this is just for me. So you don't have to worry about it at all. Let's just be ourselves and do a good class, and we want to show the camera what we normally do, okay? This is going to be for teachers helping teachers, me teaching as an example, okay? All right, so Friday we had a great class. Who was the student leader for the most part on Friday? Carlo. Yeah, Carlo was up there showing us the way. There was a lot of people helping, I believe, okay? If you weren't here on Friday, or if you're confused about Friday still, we're going to just backstep, like, right back to where we left off, and we're going to go over question 1 again, okay? Before we go over question 1, let's just really quickly talk about the triangles on the front of that page, okay? Can somebody remind us of which triangle groups were the same, or sorry, similar? Rosa, tell me one group of similar triangles. J-I-E? J-I-E? So as you look at your paper, if you weren't here on Friday, look at your paper. Right, Justin? Trying to find your paper? Look at triangles J, I, and E. Do you notice that J, I, and E look similar? Yeah. Does similar mean exactly the same?
No.
No. What does it mean?
It means sort of the same.
Sort of the same.
It's like very close.
The same how? They have the same what?
Shape.
They have the same shape, which means they have the same exact what?
Like size, but not the same height.
Angles?
Same angles, hey, but not the same what?
Height.
Not the same height necessarily, not the same side length necessarily, okay? Did anybody write the definition on the bottom of their paper?
Yeah.
Who wants to read me the definition on their paper? Oh, hold on, Luz, nice and loud.
Two similar right triangles have three corresponding angles and proportional corresponding side length.
Yeah, and look, you guys wrote that down on your paper. Just again, in case you didn't hear it, we projected it on the board. We had said on Friday 2 similar right triangles have 3 pairs of congruent corresponding angles. So the angles are exactly the same, okay? And they match up. But the side lengths are only proportional but still correspond with other side lengths, okay? So when we're talking about similar triangles, the angles are the same, the side lengths are related. Can someone give me 3 more similar triangles? Osmarlin, tell me 3 that are the same. A, D, and G? Yeah, we got G right here, we got D right here, and we got A up here, okay? And that was one thing we did. We're not going to finish that, but on Friday, we talked about groups of similar triangles. There's 4 groups of similar triangles here, okay? All right, then that brought us to kind of a more challenging question. And like we had said earlier, Carlo was leading the show here. Does someone other than Carlo want to come up and explain what we did here on number 1 and maybe model their work on the board? Anybody? Yeah, number 1. Yeah, that one there. Do you guys want to have Carla go up and do part A again? And then we can take volunteers for B, C, and D? Carla, would you like to go up and talk about part A?
Yeah.
What's going on there?
So we're trying to find where the point of 1/4 is. And in order to do that, we have to find where the point would be on the x-axis and on the y-axis. So first, since this dot seems to be closer to this point, estimated, we would use this point first. Now we need to find the x on this side. So we do the 2 plus the 1/4 because we're going positive on the x-axis. And then we would multiply this 1/4 by the 5 because down here, we're again trying to find our x. So we use the x values.
Well, why are we adding, guys? Why are we adding? Why
It's
isn't it
going-
2 minus?
Because the x is going positive.
Positive why?
Why is it going positive?
The new point is located where in reference to the original point? To the
Right? Yeah.
making it.
Positive, yeah. And now we're doing our y. So what's the y point?
And maybe someone can tell you
In
what
the
the
A?
y is.
Yeah, exactly. What's the y? In the
Jadiel,
A.
you weren't here, right? Is that how you say your name?
7?
Let's give Jadiel a chance. And Jadiel, what do you think?
Are we subtracting
Are
it
you
or
pulling?
adding it?
Uh-huh.
By the 1/4. And we are multiplying it by what?
9.
Why are we multiplying it by 9? Because we're trying to find our y axis. Okay.
Get our calculators out so that we're confirming. We don't want to leave whoever's up there on their own. We want
So-
verification.
1 divided by 4 can be translated to 0.25. So 0.25 times 5 is 1.25. And 0.25 times 9 can be
2.25.
On point.
2.25, you said?
Yeah.
Subtracting it by 7 and adding by 2. Now we have another problem. Now, let's do this side first. What's 2 plus 1.25?
3.25.
And 7 minus 2.25?
4.75.
And that is our coordinates, 1/4 of the distance of A to B. Any questions? Any concerns?
Any comments?
Any comments?
Great job. Alright, let's have someone else come up and do part B, even though some of you already have it, okay? This lesson is intended to go for 2 days, so I don't expect to finish the next handout that I'm going to give you. It's questions 2, 3, and 4. We're going to take a deep dive into number 2, and I want to see you guys talking and struggling together. I have a process that I could tell you to apply, but I don't want to tell you. I want to see what you guys come up with, okay? In this lesson, right, you're going to see some of that new notation. We're going to see this, the slope of A and B. We're going to have to determine the change in our x and our change in our y, just like Carla did, right? We're going to use this concept of a ratio, but it's important to know how to evaluate it as a fraction, okay? And then if we have time, we'll finish up with talking about part-to-part ratios and part-to-whole ratios. And all this builds up to this proportional side length concept, okay? If we can understand this, then we can understand the proportional side lengths better. Do I have a volunteer to hand out the second page? Some of you might have it, and I don't think most of you do. So Dabriani's going to hand it out. Okay. Cool. And guys, thank you so much. You're showing me exactly what I have come to expect from you. Great class. All right, so we have it on the board, what you guys are seeing in front of you. If we could take some volunteers to read, right? Even though it's math class, we practice reading, writing, listening, and speaking all the time. So let's just preview this. Do I have a volunteer to read number 2? The first.
Suppose that segment AB has endpoints at A, -3, -5, and B, 5, 7. Point C is located at -2, -7/2.
Cool. Let's hold it right there. Did they draw the line segment?
No.
No, they didn't draw the line segment. Can I do anything with endpoints? Like if I know 2 points on a line, is there stuff I can do with that?
Yeah.
Before we even look at this, what could I do with that?
Just plot them.
I could plot them, I could graph them. What did we do in Desmos? We created what?
A line.
Line, right? I could create their equation. I could do a whole bunch of stuff, okay? Do you think this relates to number 1?
Yes.
Yeah, right? So what do you think we might do then?
Graph them.
We might do something similar to number 1, right? Someone says graph them. Yeah, why don't you go ahead and graph A and B? I don't see why that's a bad thing. Go ahead and graph A and B. Need a pencil? Ooh, okay, and as I come around, Anderson's already trying to do it. You're on a good start. Make sure you have A and B graphed correctly. And that's -5, -3. So you gotta switch them, okay? You're doing X, Y, here, X, Y, X, Y, okay? But that's a great start. Do it over. If you need help, call me, or better yet, ask your partner, right? We want some peer-to-peer collaboration. Do you guys have to be silent right now? No?
Justin, you're just mad because
I enjoy the quiet, but you don't have to be silent.
Okay. Hi, everybody.
Come on, no sweat. Great start. Let's keep it going. Cool. Yeah, and you can connect them with the straight line. If you want a protractor, I have protractors. You don't need it though, but if you want one, they're up front.
Junior level
Just put the box there.
God, I have an idea. So you know, right, how this is a larger number than this the bottom, right? So 2,
Sure.
4, 6, 3,
That would be 3.
3,
Not yet.
3.5.
3.5 which is 1.5.
Yeah, so I'm gonna do -2.
Thank you.
Come on, finally.
But they both start with A, so not 2. The ratio.
One second.
Yeah, we have to start from A. And A is -3 and 5, so almost. We have to subtract,
So we're trying to
right?
find the fraction of the distance. You know how last time they gave us the fraction, and then we used that fraction.
All right,
to find
guys.
the
So on the
Oh, yeah,
board,
yeah, like
do that
right
and
here.
invert it.
on the board, all I did was write
So we need to find this.
AB is a line
Yeah,
segment.
we're basically trying to find that.
That means there's a change in Y and there's a change in X. I'm not going to tell you what that is. You need to find that.
Oh wait, I think I know how to.
They want to find the ratio of the slope of A and C to A and B, so maybe find the slope of A and C. And maybe find the slope of A and B, okay? Start with that. That's a little
Yeah, that's what I
support,
was trying to say.
okay? And remember, your main support's your partner. Let's do
If we
some
did what we
collaboration.
did, that would mean 1 unit over here, 1.5 units this way. That would make a little triangle for AC. That would be our slope for AC. So it would be 1 and 1.5. And then from AB, we would go from here all the way, and then we would be able to find the slope.
Oh, so we just have to do like the normal, like.
Yeah, like our normal thing.
So that's the, so what you found here is what? The slope of what? Yep, so that would be that one here. Yep. Exactly.
And then we have.
And make sure you don't leave him behind, okay? Pay attention. Where you at? And I know you weren't here Friday, so it's okay. Or Wednesday, so it's okay. So we'll get you caught up, all right? Do you know how to find the slope? Right? So can you find me the slope? Why don't you find me the slope of A and B to start? And then I'll come back over. Why don't you do it together so you can compare answers, okay? You guys both okay? Yeah? You okay? And if you have a question, you can ask him. Yeah, that looks really good. Yeah. So, what's your next step? And you're right. We can make a right triangle. That's what we're talking about. Right triangle. What's your next step?
trying to act as professional as possible.
I know.
We're not.
What is this?
What did we do here? Let's look at this as a resource.
Negative 3 or negative 5.
Once you do the
Subtract. That's what about you.
exactly. So apply that to
Trying to get
that.
into Harvard.
All right. Cool. I'll be back. Use that as a resource. Raceland, how you doing?
So 12 over
Let me see.
negative.
All right. So both of you are kind of in the same spot. Look, you see the do now paper?
Because it's.
Let me see that.
Come on now.
It's negative because
Yeah.
one to the left.
And you get this too, right? Can you? We have a line segment,
Positive
right?
12.
What did we start off with here?
Come on now. We gotta get the program.
It's actually, should it be
Another
negative?
line
No,
segment,
it's
right?
a fraction,
Can
right?
we apply some of this concept to this problem here? See if it gets us closer to understanding the slope of A and B? Probably is a good answer, okay? So why don't you use this as a resource?
That makes it up the
Look at what we did here and try to take a step in the right direction here
I
using
feel like
that.
Mr. would make us just round this to
Forget about C for a second. First, find the slope from A to B. You can do that. Okay? Work together. You guys are all good, right?
Yeah, we're getting some.
Strong group over here. 12 over 8. Yep. 1 over 1.5.
So then should we like?
You're doing perfect. You have all the numbers here. So now the next thing you have to do is
Why is
Why is it a negative?
It's 1.5 over 1.
Yanlin.
Yeah.
Look, you're here.
Yeah.
You have this.
Oh, that's the ratio. Yeah.
You have this.
Yeah. Yeah.
So now you need to write it like this, right? So it's gonna be,
Oh, like 3, like 12 to.
look, come on, MAC, right?
So it would be 12.
But Yanlin, I'm not gonna tell you the next step. But one more time, Yanlin, eye contact.
Yeah.
I'm not gonna tell you the last step, but you have this.
Yeah, I just put it down right now.
So make the notation into numbers, and then use this concept. You're almost there.
We have a
We have a
question.
question. Do you want us to simplify the way fractions into whole numbers?
Let's use it in fractions because they like that whole like part to whole terminology, like 3 to 2, whatever. So yeah, let's use fractions. So like here, you could make this into what?
1.5, yeah.
Well, it is a 1.5, but you had it somewhere. It was 3 over 2. Someone had it earlier.
3 over 2.
Oh, a different group then.
Oh, times 2 then.
But it's the same thing. So now how would you
Yeah, we could make it into 3 over 2, right?
how would you finish this then? Yep, so 12 over 8 divided by 1.5 over 1, and divided by a fraction is the same
Make
as.
this 3 over 2?
It doesn't matter.
You said
It
12
doesn't
over 8
matter.
divided by 1.5.
12 over 8,
Over 8 divided by 1.5 over 1.
right? And dividing by a fraction is the same thing as what?
Multiplying doesn't.
Multiplying by the.
Denominator.
By something.
We worked with it with perpendicular stuff.
By the opposite, the
Reciprocal.
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 Really?
Yeah.
That is not what I was gonna. Mister, I got my point.
What'd you get?
This is a point. Negative. We don't talk about. Okay, yeah.
What is this? Part C or part B?
Well, Mr. This, yeah, but and either I'm doing something wrong. I must be doing something wrong because this will go left and then.
What did I get on my first calculus test?
Bro, you got like a 3 out of 50, bro.
5 out of 100. True story.
Mister, I don't need to know what your sad story is because I don't want to end up like that. So I need you to help me.
You're not gonna end up like that. Did you answer part B first before we get ahead of ourselves?
That's what I'm trying to do. We're trying to get this distance from B to
Read me part B.
C located.
Read me part B. Nice and loud, Carl.
What fraction of the distance?
Yeah, read me part B. Nice and loud.
What fraction of the distance from B to A is point C located from point B? From point B.
Okay, so do we already know where C is located?
Yeah.
Sure.
Do we know anything from part A?
What that are
How far is
C is 1/8
1/8 the distance from what?
from AB.
Okay, and they want to know what for part B?
So wouldn't it be 7-8?
What is it?
7-8.
7-8. Yeah, why don't you guys struggle with that for a little bit, okay? Can you fill Carlin on what we just said? Show the difference in the notation, okay?